Welcome back, physics fans. Here we are. We're going to do question 16. It's a quiz question 16 from the Moodle here. It's a concurrent one. It's from a provincial exam and just new numbers. Here we go. Two ropes are holding together a 32 kilogram mass as shown. The angle of cable T1 with the wall is 55 degrees. Okay, so we're supposed to, and the two questions below that I've already cut off is just what is T1 and what is T2. So the mass is 32 kilograms, and there's two ways of doing it, and it is, even though it's in static equilibrium, it has nothing to do about torques. It's all about the forces acting on this little knot here, and the sum of those forces have to equal 0. So we can do it in one dimension at a time, the sum of the forces in the x, plus the sum of the forces in the y. Both of them have to be 0, and we separate them out and do them. And that way requires some interesting math, substitution math. And the other way to do it is sum of the forces equals 0, all vectors, doing all two dimensions at once. And you have to end up doing some sine law. So there's two different ways of doing it. I'm going to do it one way right now. The sum of the forces equals 0. We'll separate it into its different components. This one looks bad, but it's not that bad. Here we go. Sum of the forces. So you have to take a look at the x direction. So we have a force up here. That's 60 here, but I need to know what its angle is at the base. So this is 60, and that's T2. And then I have T1. That's up this way, and we're told that that angle here is 55, but that's no good. We want the base down, the angle to the horizontal, so that's going to be 35. So those are the two forces that are acting in the direction of horizontal east or west. Okay, and I want to get that component of it, and I want to get that component of that T2 force. This is the T1 force, and this is the T2. So I have to get the components of them, and the left has to equal the right. Okay, so the sum of the forces in the x direction have to equal 0, so the forces left has to equal the forces right. And the forces left is T1 times the cosine of 35, and that has to equal T2 times the cosine of 60. Okay, and at that point, I'm just going to isolate T1 right now. You can't solve it because there's two unknowns in here, but we can at least get a relationship here. T1 is equal to T2 times the cos of 60 divided by the cos of 35. And if you don't like the trig, just give me that number. It could be, well, I'll get it to you. Let's just do it. Hello, Mr. Calculator. Here we go. The cos of 60 divided by the cos of 35. So that number is just going to be T1 is equal to T2 times, I'll do it in brackets in black, 0.610387, whatever. Way too many numbers. That's just how T1 and T2 relate to each other. Now we have to look at the sum of the direction in the y direction. Okay, sum of the forces in the y direction have to equal 0. That means the forces down has to equal the forces up. The forces down is just this 32 kilogram object, and that's just going to be mg. So the force of gravity of that is equal to mg, and that's 32 times 9.8. And that is going to be 32 times 9.8, 313.6, 313.6 newtons. And that's going to be down. So that's the force of gravity is going to equal, and the upward forces, there's two upward forces there, and that's the T1 in the upward direction plus T2 in the upward direction. And which ones are those? Let's do up as in blue That's this component up here, and that's this component up. Okay, on this one, that's the upward force of that rope plus the upward force of that rope has to equal the downward force of that rope. Okay, that's all acting on that knot. Okay, so this is 313.6 newtons is equal to T1 up. T1 up is, there's my little diagram of it, and that's going to be the sine of 35 times T1. That's going to be T1 times the sine of 35 plus, and this one is T2 times the sine of 60. Okay, at that point, we had a relationship here between T1 and T2, and here we have another relationship between T1 and T2. So this is just two equations with two unknowns. So in math 8, it would have been like y plus x equals 10, and y minus 2x equals 3. What is these two? And these are just two lines, and you have to find out where they intersect, if that's the way, but you're trying to find out how to do it. How do you solve this? So if you have two equations, two unknowns, you isolate one of them and substitute it. So this one, you go y equals 10 minus x, just rearrange it, and then put that into wherever y is on this next one. So we go 10 minus x, that's our y, and then we have to subtract 2x equals 3. Okay, so you get 10 minus 3x equals 3, and then minus 3x is equal to negative 7, and away you go. You solve for x. Once you get x, you plug it back in here and you get y. So that's what you do when you have two equations, two unknowns. That's the science, that's the math 8 of that, or math of probably 9 when you started doing that. Here's our two equations, two unknowns. You solve for T1, put in where T1 is, this value here. So I'm going to do it without doing this step here, even though that's just a relationship. I'll go 313.6 newtons is equal to, now instead of T1, I write down this, T2 cos 60 over cos 35. That was T1. Then I have to multiply it by sine 35 plus T2 sine 60. Now you might scream, and it's only screaming because there's just lots of numbers and signs, but this is just all plug-inable into your calculator. Or if you're truly sadistic, you could isolate T2, and I'm going to do that. 313.6 n is equal to T2 times these three trig functions, cos 60, and I'm going to surprise you here. Whoops, I didn't write down the 60. Cos 60 times the tan of 35. You see where I got that? Plus the sine of 60. Because it's just sine 35 divided by cosine 35. So you don't have to write the tan there. I'm just being sadistic. At this point, most people will just plug in the numbers and come up with these two numbers. What numbers am I talking about? When I multiply those two together and divide by cos 35, that's just a number. And that's just going to be a number. And then I'm just going to add that number plus that number to be how many T2s we have. Or I'm doing it painfully, and so T2 is going to equal 313.6 divided by that bracket, which is cos 60 tan 35 plus sine 60. Okay, so let's just pop that into the equation here. 313, I'll take that answer and divide it by, in bracket, cos 60, close the bracket, that's a 60, not 6, tan 35 plus sine 60. Close the bracket and close the big bracket, and there we go. So T2 is just going to be a number, 257.9. Okay, and then you just plug that in up to here to get T1. Okay, and then I'm going to multiply T2 times cosine 60 divided by cosine 35. So times cosine 60 divided by cosine 35, and I get T1. So this is T2, and T1 in a few seconds drops out as 157.4 degrees. Okay. So 257.9 and 157.4. There we go. Next video, I'm going to do it in 2D triangle. Easier, quicker, but can make a bigger mistake if you don't like the geometry. Thank you.